We are right in the middle of a massive global AI gold rush. And everyone knows the famous names designing the chips and the giant foundries printing them. But behind the scenes, there's an indispensable Japanese titan quietly powering this entire technological revolution. We're talking about a company that controls the absolute hidden critical steps of semiconductor manufacturing. They hold a near monopoly that, honestly, most people have never even heard of. So today, we're unpacking the structural realities, the massive financial moats, and the geopolitical vulnerabilities of Tokyo Electron Limited, or TEL.
Here is our quick roadmap for today's explainer. First, the invisible semiconductor giant. Second, the coder and developer monopoly. Third, the cyclical revenue wheel. Fourth, financial fortitude. Fifth, geopolitical risk regarding China. And finally, we'll wrap up with the future of Tokyo Electron. Let's jump in.
Section 1. The invisible semiconductor giant. Founded way back in 1963, Tokyo Electron Limited is currently the third largest semiconductor equipment manufacturer in the world, and they're actually the only Japanese company sitting in the top tier of the global Semicap rankings. Now, to be clear, they don't make the chips themselves, they make the incredibly complex machines that make the chips.
Which brings us to a really fascinating question. Who actually controls the hidden steps of chip manufacturing? If you think of the semiconductor industry like a modern gold rush, giants like TSMC, Samsung, and Intel are the miners pulling the gold out of the ground. They take the direct hit from the supply and demand cycles of consumer electronics. But Tokyo Electron? They're the ones selling the irreplaceable pickaxes and shovels. It's a completely different business model and fundamentally a much more defensible one.
Let's break down how this creates a continuous, unavoidable manufacturing flow. Right in the middle of this process, at step 2, you have lithography. That's famously dominated by the Dutch company ASML. But look at what surrounds it. Before ASML's machine can print a pattern, a TEL coder system has to apply a light-sensitive photoresist. And immediately after the pattern is printed, a TEL developer system has to reveal it. From there, it moves to the etch process, where TEL is also a massive global player. So TEL literally surrounds and supports the most famous machines in the entire industry.
Moving to Section 2, the coder and developer monopoly. While TEL competes really fiercely in etching and deposition, the coder and developer segment is where their true and often overlooked technological moat lives.
The sheer dominance here is just wild. In etch and CVD systems, TEL holds a very solid 20 to 30% of the global market. But in the coder and developer segment, Tokyo Electron commands an astonishing 85 to 90% global market share. Guys, that's essentially a quasi-monopoly. It didn't happen overnight. It's the result of decades of hyper-specialized R&D and grueling multi-year certification processes with clients like TSMC. At this point, the switching costs for a foundry to move away from TEL are almost impossibly high.
And this dynamic creates an absolutely fascinating symbiotic relationship. Every single time ASML sells one of its cutting-edge extreme ultraviolet or EUV machines, the foundry buying it has no choice but to buy multiple coder and developer systems from Tokyo Electron to support it. So as ASML continues selling over 100 of these incredibly expensive EUV machines every year, TEL just automatically benefits. They get to ride the wave of the most advanced lithography in the world, and they do it without carrying the intense regulatory spotlight that usually hits a true monopoly. All right, Section 3, the cyclical revenue wheel. To really understand Tokyo Electron, you have to understand the financial realities of the semicap industry. It is notoriously volatile.
We're basically contrasting short-term pain with long-term gain here. Historically, the semiconductor equipment sector goes through brutal cyclical down cycles every few years. During these 18 to 24-month periods, chipmakers completely slash their capital expenditure, and TEL can see revenue drops of 20 to 35%. That's rough, but driving the long-term secular gain is structural miniaturization. As chips shrink from 3 nanometers down to 2 and eventually to 1.4 nanometers using next-gen 3D transistor structures, the sheer number of steps required to make a single wafer absolutely explodes. So even if global wafer volume stays perfectly flat, the industry requires more TEL machines per wafer just to keep advancing.
So, knowing that these brutal 30% revenue drops are just a normal part of business, how does TEL actually survive them? Section 4, financial fortitude and margins. TEL has deliberately built an absolute financial fortress. The really crucial point here is this. During an upcycle, TEL easily hits massive operating margins of around 27%. But look at the down cycle of fiscal year 24. Revenue plummeted, yet their operating margin barely dipped to 21%. That is still more than double a standard industrial average. How do they pull that off? It's all about aftermarket services.
Things like replacement parts, maintenance, and upgrades for their massive installed base of machines worldwide make up about a quarter of their revenue. These services carry exceptionally high margins and basically act as a solid floor when new machine sales dry up.
On top of that, TEL operates with incredibly disciplined Japanese corporate culture. Just look at their capital allocation. They target a 50% dividend payout ratio, and even during the severe 2023 and 2024 down cycles, they completely refuse to cut that dividend. They also pour about 11% of their massive revenue straight back into R&D, making sure they maintain that technological lead for the next cycle. And they can afford to do this because they operate with almost zero debt, huge net cash reserves, and an AA credit rating. It is literally a balance sheet designed to sleep soundly through industry crashes. But of course, balance sheets can't protect you from governments. Section 5, the geopolitical risk of China. We have to take an impartial look at the biggest external, non-technological threat facing Tokyo Electron today, and that's the ongoing US-China trade and technology war.
Tracing the objective escalation of these controls really paints a picture. In October 2022, the US implemented sweeping export controls on advanced semiconductor equipment heading to China. Now, while TEL is a Japanese company, immense diplomatic pressure led Japan to implement its own export controls on 23 Semicap categories in 2023. The impact was immediate. Before these controls, China accounted for nearly 40% of TEL's total revenue. Fast forward to fiscal years 24 and 25, and that massive addressable market was forcibly shrunk down to between 25 and 30%.
And moving into late 2026 and beyond, there is a very real binary business risk. Currently, TEL is still allowed to sell older, mature technology nodes to their Chinese clients. But if a new US administration decides to tighten restrictions further, specifically expanding controls to mature 28-nanometer equipment and above, it could instantly freeze an additional 15 to 20% of Tokyo Electron's remaining revenue. This is a purely political risk. It's incredibly hard to model precisely, but it's an ever-present shadow over the company right now.
Section 6, the future of Tokyo Electron. How do we actually synthesize this level of absolute technological dominance with such stark geopolitical vulnerabilities?
There's this fantastic court insight drawn directly from the analytical data of our source material. It states, Western analysts focus on etch and deposition, systematically undervaluing the coder/developer as TEL's most defensible moat. I think this brilliantly illustrates why Tokyo Electron remains a hidden giant. While everyone is arguing over who makes the best etching machines, TEL is quietly sitting on a 90% monopoly in coding and developing. It's a step that is literally mandatory for every single advanced chip manufactured on Earth today.
So we conclude today's explainer with a really vital question. Can a 10-year technological gap protect TEL from the shifting global geopolitical landscape? The data shows us that Chinese domestic competitors like Naura and AMEC are still an estimated 8 to 12 years behind TEL in these critical segments. So technologically speaking, TEL's moat is virtually insurmountable in the near term. But as we've just seen, when diplomacy and export controls step in, technology suddenly takes a back seat. TEL is an undisputed engineering marvel with a bulletproof balance sheet, but as the global market fragments, geopolitics absolutely remains the ultimate wild card for this invisible titan. Thanks so much for joining me today, and I hope this gave you a much clearer view of the quiet giant powering our AI future.